Good morning, mathematicians. Today we're doing lesson 6.3, the partial quotients division algorithm. Our learning target then is that we're going to introduce and practice with a low-stress division algorithm for one-digit divisors. Let's get warmed up with just some problems here, some mental math. For each one, give me a thumbs up or thumbs down. There are at least 2 5s in 11. True. There are at least 3 2s in 5. That's false. There's only 2 2s in 5. There are at least 4 3s in 14. True. There are at least 7 6s in 45. True. There are at least 9 8s in 67. There are at least 8 9s in 75. And finally, there are at least 10 8s in 92. There are at least 36s in 157. There are at least 40 9s in 391. Take a look at this statement that was false. There are at least 36s in 157. You're going to turn and talk and share with your partner, why is this false? How do you know? And what would make it true? Go ahead, turn and talk. Today we're going to be working with partial quotient way of doing division. When we set up a division problem like this one, this is actually 127 divided by 7. This first number, the 127, is called the dividend. The number that we're dividing by is called the divisor. So let's go ahead and see what we do for partial quotients. It's much like our warm-up that we did yesterday, where we pull out some different groups of 7 from 127. So remember yesterday we talked about how a good place to start is always 10 groups of the number. So over here on the right, if we did 10 groups of 7, it would be 70. 20 groups of 7 is 140. 50 groups of 7 is 350. Oops. And then let's go down this way. So we have 5 groups of 7 is 35. It looks to me like the group that gets the closest is the 10 groups. So in our problem, what we do is we write down that we want to have 10 groups. We put it over on the right. 10 groups of 7 is 70. So we're going to subtract 10 groups from our 127, our dividend. 7 minus 0 is 7. 12 minus 7 is 5. Then look over here on the right again. Well, how many groups of 7 can we take away from 57? We can't do another 10 groups. That's 70. We can do 5 groups, though. So 5 groups of 7 is 35. So we'll subtract 35. 7 minus 5 is 2. 5 minus 3 is 2. Let's see. How many more groups can we take out? I know that 3 groups of 7 equals 21. That's really close to 22. So let's do that. So I can subtract here 3 groups of 7, which is 21, and I'm left with 1. I only have 1 left. I can't take a group of 7 away from that at all. So let's see how many groups I took out. I'm going to add them up. 10 plus 5 plus 3 is 18. So at the top of the problem, I'd write down 18. I took out 18 groups of 7, and there's a remainder of 1. So when we do this, keep in mind that your dividend's in the middle. Your divisor is what you're dividing by. These are your groups that you've taken out. And the bottom number, that's your remainder. This might seem a little confusing right now, and that's okay. If you got it, great. You're going to be able to do this on your own today. But if you feel a little stuck, that's totally normal. We are just starting this brand new. So we're going to practice some of this together. Right now, go ahead and turn ahead in your math journal page to page 144. On page 144, we're going to try number 4 together. Who would like to read that for us? Okay, so from yesterday, we know our number model with our unknown, that we're taking 1,325, we're divided by 9, and we're trying to figure out how many straws, so S. So let's set up our division problem then. So on your page, you're going to write 1,325 as your dividend, your divisor is 9, and then drop this line down because your groups will go to the right. Let's think of some groups before we start. We always start with the 10. So 10 groups of 9s is 90. That's not even close to our answer. So let's go 20 groups of 9s is 180. What if we went all the way to 100 groups of 9s is 900. Well, this 100 is definitely closest. So we're going to take out 100 groups of 9s, which is 900. So write your 100 on the right, your 900 underneath, and then you're going to subtract. 5 minus 0 is 5, 2 minus 0 is 2, and 13 minus 9 is 4. Okay, let's go back to our groups. Do we have one that's pretty close to 425? No, not yet. So let's do some more. I think if I double 20, if I do 40 groups of 9s, that might be close. What is 40 groups of 9s? Right, 360. That looks pretty good. So let's take out 40 groups. So I'll write my 40 on the right. 40 groups of the 9 is 360. So subtract 360. When we do the math, we have 5 minus 0 is 5. Oh, we need to do some trading. We can't do 2 minus 6. Go next door, take 1 away from the 4. Carry the 1 over by the 2. So 12 minus 6 is 6. 3 minus 3 is 0. Alright, now we have to go find how many groups of 9 we can take out of 65. We can't do 10 groups. That's 90. Well, 9, let's just think this through. How many groups of 9s would get us really close to 65? Right, 7 groups of 9s is 63. So if we write down 7 groups of 9, we would subtract 63 then. 65 minus 63 is 2. Then we add up our groups. 100 plus 40 plus 7 is 147. And we have a remainder of 2. So in our math journal page, we know the answer is 147 straws. How many are left over, or how many remain, would be 2. In our summary number model, then, we write our open number model, so 1,325 divided by 9 equals 147, remainder 2. We're going to try one more together from the next page. So take a look at number 7. Go ahead. This is one of those multi-step story problems. So a factory has 372 boxes of shirts to distribute evenly among 12 stores. So we know right away we're doing 372 divided by 12. Each box needs 15 shirts. How many shirts will each store receive? So now, what are we multiplying by and why? Okay, so we have 2 steps here, and we could just say equals S for shirts. We are just going to do the first part of this problem together, the 372 divided by 12. You'll do the rest on your own. So I will write down over here to remind you that you're doing 372 divided by 12, and that whole thing times 15 equals S. So if we have 372 divided by 12, set up your division problem, and let's come up with some groups. How many groups of 12s can get us as close as possible to 372? We always start with just 10, because it's easy to multiply. 10 times 12 is 120. It looks like we can about triple that, because I know 100 times 3 is 300. So instead of doing 10 groups, let's do 30 groups of 12s. 30 times 12, well, 3 times 12 is 36, and add a 0. So let's write that down. we're taking away 30 groups of 12, which means we're subtracting 360. 2 minus 0 is 2, 7 minus 6 is 1. Oh, well this is nice. We are taking away groups of 12 from the number 12. Well, that's one group. So we subtract one group of 12, which is 12. 12 minus 12 is 0. So our answer is just 31, no remainder. When you finish this problem, you're going to have to take the 31 times the 15 using either the partial products, multiplication, or your mom and dad way to finish solving this problem. The other final page you'll be doing today is just a review of place values in your decimals. So let's go over what you're doing today. First of all, we have a Math Masters page that's available to figure out the easy multiples. You noticed on some of the pages I just jotted them on the side, but other pages I used an actual worksheet that walked me through what multiples I could do. You may use that same worksheet here. Then you're finishing your Math Journal page 144 and 145, the partial quotients division algorithm, reviewing with decimals, and finally math boxes. If you're in activity B, you're going to come back to my room and we're going to play a game called Making 10. Activity C, you have a Math Masters that you'll get from Mrs. Paczynski called a pen riddle, and then you do your blend space, practice D. Listen up closely because we're going to pull some different groups today, and listen for your name so you know where you're going to be starting.